Let's discuss a question from thermodynamics. So basically we are dropping a copper wire into an insulated rigid tanks, okay, and this is water, and you drop a copper piece into it, okay. Remember that it's insulated everywhere. So now we consider this copper plus our liquid water as one system, okay. So for this system, if we apply the first law, so Q is the net heat transfer for the system is del U plus change in work done. Now because we consider this water and copper as one system, so there will be heat transfer from copper to water, but then if you consider together as a system, from the system, because the tank is also insulated, there is no heat transfer, so Q is 0 and del U is there is no work done, so change in internal energy of the system has to be 0. Now system is now comprised of water and copper, so copper plus water is equal to 0. Or the other way you can see the internal energy decrease. Now copper is hot, okay, so there will be a decrease in internal energy of this with the that will result in an increase in internal energy of the water. So let's just substitute the specific heats. Now for a solid, change in internal energy is m into s into delta T, that is mass into specific heat into delta T. So for the copper, mass is 0.6 into specific heat of copper is 0.393, okay, 0.393 into change in temperature. So here we assume that the change in temperature, final change temperature is T2, initially it is 100, plus change in temperature of the change in internal energy of the water. You have 0.75 kg into specific heat is 4.184 into delta T. Well, finally they will attain equilibrium temperature, but initially it was 25, so T2 minus 25 is equal to 0, okay. So this, what we can do here is, the other way of telling it is that 0.75 is 0.75 into 4.184 into T2 minus 25. This is the change in increase in internal energy of water with a decrease in internal energy. So if you bring to that side 0.6, the copper part, 0.393 into, it will be minus, so 100 minus 3. So this is decrease in internal energy of copper with the increase in internal energy of water. So now you have to just solve for T2, and when I solve for T2, I get 30.24 degrees Celsius. So finally when you drop the copper into the water, and finally when they come at equilibrium, at that point you have applied the energy balance, and we got 30.24 as the answer. So this is just energy balance problem, first law of thermodynamics. Thank you.